So the next step is to use Excel to calculate our accuracy statistics, the root mean square error and the mean absolute difference of error based on the validation extract file that we created in ArcGIS from our model in Model Builder. So to review, the root mean square error takes is a calculation that quantifies the accuracy of a surface based on a set of truth, and the truth we have were those points that we extracted from the validation. So on a per point basis, we're going to take the square difference between what the truth would have been if it had been included and the interpolated value at that location, square it so that there's no negative numbers, and then move on to the next one. And then we take the average of all of those almost 10,000 points and then unsquare it, and that's our root mean square error. The mean absolute difference, instead of squaring the difference, takes the absolute value of the difference. So it's a little bit more conservative. It doesn't give more weight to values that are farther away. And these are our formulas, and that's what we're going to implement in Excel. And this is the file that I'm going to open in Excel, the DBF file. So I have an Excel workbook, and I'm going to go to File and navigate to that file and open it. And when you navigate to that file to open it in Excel, you have to make sure that you select all files so that you see all the files, and then you see that validation for extract DBF. I'm going to highlight that file and open it in Excel. And let's take a look at what we have. So we have all of the information, the layer, and all of the data associated with it. And I am just going to format my columns so that I can see all of them and delete the ones that we don't need by highlighting them and making them a little bit smaller. It shows that we can get rid of this layer because we don't need that. And I'm going to delete that. And I have my elevation, and it takes it out to significant digits actually that are interesting because we didn't measure to that significant digit. And then the co-located values. So I'm actually going to keep this raw data in this workbook and open up a number of different workbooks to calculate my values. So let's just start with the IDW. We're going to do it by grid cell resolution. So I'm going to add a workbook, and I'm going to rename it Accuracy 0.25. So we'll focus on the accuracy statistics at 0.025. So I'm going to copy all of this, Control C, and then put it in this workbook, Control V, and I'm going to delete anything that's not 0.25. So I'm just working with my spline, inverse distance weighted. I'm sorry, my inverse distance weighted spline and natural neighbor at 0.25. So these are the ones that I want to calculate accuracy statistics for. Okay, so the next step is, now that we have that, let's start with IDW, and I'm going to just insert some columns here. Whoops, that's not what I wanted to do. I want to insert, not delete. Okay, so the first thing we want to do, and let's do some Excel tricks of management. I'm just going to highlight these. I'm going to make these columns bold. I'm going to just show my numbers with 2 decimal places. I'm going to, with it highlighted, if I double click the column, it just makes the column width the width of the numbers. And I'm also going to make that underlined, and I'm going to use freeze pane. So I'm going to go to View, Freeze Panes. So as I go down, everything is I still see these columns at the top. The other thing that I want to do is highlight these columns, and I'm going to go to Data and Filter, and that allows all of these to be sorted but maintaining their relative position. So I want to make sure I don't have any negative numbers in here. So I'm going to go smallest to largest in IDW, smallest to largest in spline, and smallest to largest in natural neighbor to make sure I don't have any negative 999 numbers. And I do have some in natural neighbor, so I want to make sure that I get rid of these. So I'm going to delete these because those may have been just points that were on the edge and were not included. And just to be consistent, I'm going to delete them in all of them. So now we have no weird outlier numbers. and we can move on. Okay, so I have my IDW. I'm going to calculate the RMSE and mean absolute difference for IDW first. So the numerator in the RMSE calculation is the square difference. So I'm going to call this SQ diff, square difference, and this will be the absolute value of the difference. So for this column, I'm going to do equals to, and then just take the elevation or the truth minus the interpolated and parentheses and use the caret and square it. And for this column, I'm going to say equals ABS for absolute value of the elevation minus the interpolated value at that location. And I have both of those. And I can do the same for spline and natural neighbor, but we need to make sure that we change it back to elevation. So this needs to be A minus E. So you want to make sure that you have this value A minus E is this value A minus this value in the E column, and this one is also A minus E. A trick to that is you could put a $sign in front of the symbol so it always maintains it, but we'll just make this. Oops, I screwed something up. This is going to be A2 minus H2, and we're just double checking, and this is going to be A2, the value. So we have these values. So I'm just going to start with my RMSE for IDW at 0.25, and I'm going to Control C, and I'm going to highlight all the way down to the end of my data set down here till I get to the bottom, and I'm going to copy that formula there. So now for every single cell I have, or every single value I have the square difference and the absolute value of difference. Well, if we go back to our formula, the RMSE is equal to the sum of the square difference on average, and then take the square root of that. So let's take, we want to do equals sum, and we want the sum of all these values. So we want the sum of all that. So that's the sum. And we want to take the average of that. So we need to know what the count is. And just for fun, we can do count. You do the count, or the N, is equal to count. You can put a formula in to count all the values, even though we could just tell by the rows. But we could do count, and then in this data set, our N is equal to 9993. So on average, we want equals to the sum of that divided by 9992, which is N minus 1. And that's on average the square difference. And then we want to unsquare it and take the square root. So we want the square root of all of that. So our RMSE for IDW is 0.675. And let's double check, it's the square root of the sum of the difference. And if we want to just, that looks right. And so for this one, we want to just take the average. So is equal to the sum, you could do mean, but we'll just put the numbers in. Just going to go all the way to the top. So that's the sum of the absolute value of the difference divided by this count, 9993 minus 1. So you could actually just say 9992. And the mean absolute difference is 0.31 meters. I'm actually not a big fan of all of these values, so I'm going to go to format the numbers and just give it 2 significant digits. Okay, so this is our RMSE, and this is our MAD for IDW 0.25. And here's a little trick. Once you copy those values down, you can just copy the formulas at the bottom. So we're going to do this, and we can just copy all of this down, and then we get our mean absolute difference in RMSE for for spline at 0.25 meter resolution and for natural neighbor. So I'm copying those formulas down, and now I can copy the mean absolute difference in the RMSE to these columns. So I'm going to copy that and paste that there and paste that there. And so the RMSE change this to SPL for spline at 0.25 meter resolution, and the mean absolute difference for SPL. And here we have the RMSE for natural neighbor at 0.25 meter resolution and the mean absolute difference for natural neighbor. Okay, so what is this telling us? This is telling us that IDW is not as accurate as spline or natural neighbor for the RMSE. So the RMSE for natural neighbor was the most accurate. It shows us that natural neighbor was the most accurate, but according to the mean absolute difference, IDW was the most accurate. So we have different values calculated, and these are what I'm going to have you tabulate at the end and compare. So I've done this for you doing accuracy at 0.25, and now you add another spreadsheet in, accuracy 0.5, and repeat. Lather, rinse, repeat. Copy this into this spreadsheet. Oops. Copy all of the original data, and I'm going to delete anything but 0.05 for 5 meter resolution. Let's get rid of the number here. That's number general. Make it 2 decimal places. We can format it again, and now you're off. You can do it yourself. You can insert the columns for the square difference and the absolute value of the difference, and do your calculations there. Again, actually, before we do this, let me do that. Before we do this, let's check to make sure we have no minus 999, so we can highlight these columns and go to data filter, filter smallest to largest. We have some in IDW, so I'm going to delete that, and I'm going to do the same for spline, smallest to largest, and natural neighbor, smallest to largest. We have a bunch in natural neighbor, so I'm just going to delete those. And yours may be different because you had a different sample data set, and now you can move on and go forward with the calculations. So you want to insert, and then you can go back here and copy and paste your formulas, just double check that they're okay. And there you have it. This is how you calculate your RMSE and your mean absolute difference. So if we go back into the lab file, what I want you to do is, after you've played around with your data set in Excel, produce a table. So you have a table of your inverse distance weighted at each grid cell resolution, your spline at each grid cell resolution, and your natural neighbor at each grid cell resolution for the RMSE and the mean absolute difference. And this time is what you're pulling out of that text file that you took when you finished running the model. So this is what you're going to turn in, and as well as your write-up as instructed, and I look forward to seeing your results.